Hello everyone, my name is Ryan from Dom Labs, and today we're going to be doing the tutorial Pong. In this tutorial, we will be learning all about how to make the game Pong, but mostly focused on the UI, because the game Pong is not that difficult to make code-wise. We will learn how to make a score screen and lots of buttons, a beginning screen, and the points will go up as the player and computer both win. The computer will have AI to follow the ball, to hit it, and you will be able to move the player and hit the ball back to the computer side. So, to start making our project, we're going to go into the Unity Hub and then click the New Project in the upper right-hand corner. When we click that, we're going to get a screen like this. It's going to have all of the templates that we can use, like 2D and 3D. We are going to have information about our project and then our project version. I'm going to use the project version 2022.3.12, but you feel free to use whatever version that you would like to use. Instead of 3D, we're going to do 2D because Pong is a 2D game. For project, we're going to have Pong, and then you can choose the location in your files to what you would like. I have this as right here, and then you're going to click Create Project. Your project will then load up. Mine will not because I already have a project with the name of Pong, so you cannot create two Unity projects with the same name. Once you click the Create Project button, the Unity project will start loading up and it will start to compile. It does sometimes take a long time to compile when you first load up your project, so be patient, but when it finally compiles, come back to this video to start working on the tutorial. Alright, so when you load up your Unity editor, you will come across to a screen like this. To start off this tutorial, we're going to do some scene setup for Pong. So we're going to create the ball, the dividing line in between, and both the player and computer paddles. So to start this off, let's go into the hierarchy, right click, you do 2D objects, sprites, and then a square. We can name this player paddle because it will be the player paddle. And then right now, all we just have is a square, but we're going to want to change this to look like a paddle. The position, we're going to keep it 0, 0 because we can just move it on the X and Y. The scale, we're going to change, but if you move the X, it can scale on the X and it can scale on the Y. So we can set this back to 1 and 1 and set the position back to 0 and 0. So for the scale on the X, how about we put 0.5 and then the Y we can put 2. So that looks like a nice paddle, which you'll be able to move up and down on the y-axis, like this, to be able to hit the ball. But we're not going to want to move the y-axis, and we're going to want to change the x-axis. So let's do negative 7.5, so it moves all the way over to this side of the screen, so you'll be able to move it up and down with the y-axis, so 5, negative 5, all that stuff, and then we have the player paddle just right there. And we just have these two components on it, but we're going to want to add some more components. So let's add a box collider 2D to it and a rigid body 2D. Right now, the rigid body 2D has gravity attached to it. If we play this scene right now, you'll be able to see that the player will go all the way down because the gravity is affecting it, and then we'll just be able to see it for a few seconds until it falls all the way down. And we don't want that because we're going to want to be able to move the player up and down on the y-axis with our controls from the input. So you see it just went down. We can look at the scene view, zoom out, and you can see that little dot right there. That's our player paddle just falling down. Alright, so we don't want that. So we get out of play mode. We can go back all the way to the main camera. And then for the rigid body 2D, we're going to set the gravity scale to 0. We can also set the angular drag to 0 because we're only going to be moving it up and down on the y-axis and not on the z-axis. And since we're only going to be moving it on the y-axis, we can freeze rotations on the x and we can freeze rotations on the z-axis because we don't want this turning in circles. So let's create another 2D square. We can name this computer paddle. We're going to reset the transform and we're going to do the same exact thing that we did for the player paddle, because the computer paddle is the same. So for the scale in the x, we're going to put 0.5, scale for the y, 2, and the position, instead of negative 7.5, we'll put positive 7.5. There we go. And then on computer, we're also going to put another box collider 2D and another rigid body 2D. But for the rigid body, we're also going to set the gravity and the angular drag to 0 and freeze rotations on the z and x axis, so it cannot move. Now we're going to make the dividing line in between. So we can right-click on the hierarchy, 2D objects, sprite, and then a square. We can name this dividing line. This is not going to have a box collider or a rigid body 2D on it, because it's just going to be in the background of our scene. So we can reset the transform, but a quicker way to do this is to right-click on the transform and click reset. For the scale on the x, we can do something like 0.25, and on the y, we can do 10, so it stretches all the way to there. And maybe on the x, we can do 0.2, just to make it even more small. So we're going to now create the ball. So create 2D, sprites, and then a square. We're not actually going to create a ball just because a square would fit in with the blocky theme of Pong, so a square would work fine for us. So you can just name this ball, and that is much too big to be a playing ball, so we're going to reset the transform and then set the scale to 0.25, so it looks like a small ball. But now it's in the dividing line, so we don't actually want that right now. We can set the position, let's just set it on 2, so it's just right there now. When we finalize this game, we are going to reset the ball's transform, just so it always starts in the middle, but just for testing purposes so we can see it, we're going to set it out here. We are also going to add a box collider and a rigid body 2D to this because it's going to be moving around and colliding with things. The rigid body 2D, we can set the gravity scale and the angular drag to 0, and instead of freezing the positions on the x and z axis, we only want to freeze the rotation on the z axis because we want this ball to be able to move on the x axis, so it'll be able to go left and right, and also it will also be able to go up and down. So now we have our scene set up. This scene is basically just all of the game that we'll need for Pong, but we can also add some UI, and we'll be doing that later in this tutorial. But right now we're just going to create the movement for the player, the ball, and the computer. So inside of our project folder, we can right-click, create a folder. We can name this scripts for all the scripts that we're going to put into it. And inside of this folder, let's create a new C# script. We will name this player movement because all of this script will have all of the player movement inside of it. Right now, we can double click on this script and it will open up in Microsoft Visual Studio. That is going to be the code editor that I'm going to be using, but you can also use Visual Studio Code. If your Visual Studio Code has an error that my Visual Studio doesn't have, I would suggest changing your project settings back to Visual Studio so that you can see if you have the same code in both code editors. Now, sometimes this takes a while to load up, so just be patient, and then once it loads up, you can come back to this tutorial and finish coding. Now, once your code editor loads up, and it only takes a while the first time, you will come across a screen like this. We have two methods already in here, start and update. As these little comments tell us, start is called before the first frame update, so you can put all of the things that you need to put before the game starts instead of start, and you can put all of the physics-related things inside of update because update is called once per frame. It's used for moving and physics and collisions and stuff. Right now we can just delete those methods because we won't need them right now. So to start off, we're going to need a public reference to our rigid body 2D. We can name this rigid body 2D because so we'll know what it is. And then once we have this reference, we're also going to want to have another public reference. We're going to want to have a public float. We're going to name this speed. We can name this paddle speed. We can we can set this paddle speed to be whatever we'd like, just so to fit our needs. But for right now, I'm going to set this to 5. So inside of update, that function that is called once per frame, I'm going to create another. It's going to be a float, and we can name this vertical movement. And we're going to set this equal to input.get axis raw, and then parentheses, and then this is going to be a string, and inside of the string we'll put vertical. This is just saying that we would like to get, whenever we push the W or S or the up and down keys, we're going to want to set that to a float value. So if it's the W or the up key, it will be 1, or the S or the down key, it will be -1. And we can set, we want to be able to check which one is being pushed so we can move our player in the correct direction. So now we can do a get our rigid body 2D, and we can add force to it. Add force is a method that basically just adds force. So it's a vector 2, so we're not going to want to add any force in the x direction or in the x-axis, but on the y-axis we'll want to do vertical movement times our speed. Now this is just adding force times our we named it paddle speed, and we're taking either the up or the down, and we're multiplying it by the paddle speed, and we're getting an error here right now, and that is just because it doesn't take these two as a vector 2. So we can highlight these two, put them in parentheses, and then outside we can put a new vector 2. And then it just creates a new vector 2 with these two as the parameters, and that is what we're going to do, is add force. So we can go back into Unity and wait for the Unity editor to compile. Sometimes this Unity editor does take a long time to compile too, so if yours takes a really long time, then just be patient and then come back to finish this tutorial once your Unity editor has fully compiled. What we're going to want to do now is attach our player movement script to our player paddle so we can move the player up and down. We're also going to create another script called computer movement, which is basically going to be the same thing as the computer, but instead of the up and down arrow keys, it's going to be determined by the position of the ball. So right now we can go into the player paddle, go down, click add component, and then type in player movement, this script. Right now, we have it right here, and it's looking for a reference for a rigid body 2D. That will be our rigid body 2D, so we can just take our rigid body 2D and drag it in. We have the paddle speed as 5, which is good because we will check if that's good once we start to playtest this. And now let's create another script called computer movement. This will hold all of the computer movement that is determined by the ball position. So the computer will move up and down so it can hit the ball and move the ball back towards the player. Now you can double click on the script to open it inside your code editor, and then you will come across another basic script like this. We can once again delete these methods because we're not going to use them right now. And then once again, we are also going to need a public rigid body 2D reference. We can also name this rigid body 2D because we need to know what our variables mean. We can also create another public float. We can name this computer speed, and that will be the speed on which the computer moves up and down towards the ball. We are also going to need a public game object reference. We can name this ball object, because we're going to set this as the ball object in our Unity editor, because we're going to need to know the position of the ball in order to move the computer paddle up or down. So inside of update, the method that gets called once per frame, we are going to have some if statements to check if our position is above or below the ball object position. So if transform.position .y, that is checking our y position, the computer paddle's y position, and if this is greater than the ball object .transform .position .y, this is checking if our position is greater than the ball's position on the y-axis. So if the computer paddle is higher up than the ball, we are going to want to move the computer paddle down. So we can do rigid body 2D, and we're going to do this same method. We're going to add force. Now, again, we can do a new vector 2, and then inside of that vector 2, we're going to want to move 0 on the x-axis because we don't want to move the computer paddle at all. And then we will just do computer speed. Since the computer is not being controlled by any movements at all or inputs, we don't have to have another float for the movement speed. We can just have the computer speed. Now we can do an else if statement. Else if transform dot position dot y is less than ball object dot transform dot position dot y. So if the ball is higher than the computer paddle, we are going to want to move down. So we can do another rigid body 2D dot add force, and then a new vector 2. We're going to want to move 0 units on the x-axis, but instead of computer speed, we're going to want to do negative computer speed. We're going to want to move down. So that is all good. So this is just checking. This is the code that will make the computer move up and down according to the ball position. So this is good, but we only want the computer to move if the ball is moving towards it. So we want this to be fair. So if the ball is moving towards the player and not towards the computer, let's have the computer move towards the middle, because it would be much nicer if the computer was at the middle and it could go either up or down according to where the ball would be. So outside of all of these if statements, let's have another if statement. And then we can check ball object. We are going to want to check the velocity, or we can check the transform dot position dot x actually. And then if this position dot x is greater than 0, that means it is going towards the computer side. We can just cut and paste this code into here. So now if the ball is going towards here, we will want to move the player. And now else if ball object dot transform dot position dot x is less than 0, we are going to want to move the computer paddle towards the middle. Now we can just check if the computer paddle is either above or below the middle. So if transform dot position, if we can check if the transform dot position dot x or dot y is greater than 0, and then this is checking if the computer paddle is is above the 0 mark, we're going to want to move it down. So we can do a rigid body 2D.add force, and then we're going to want to move down. So it'll be a new vector 2, 0 on the x-axis, and then negative computer speed on the y-axis. But yes. And then we can do an else if statement. If the transform.position.y is less than 0, then we're going to want to move up, because this is if the computer paddle is under the 0 mark. So we'll do a rigid body 2D dot add force, a new vector 2, zero on the x-axis, and then positive computer speed on the y-axis. Now, this is all the code that basically just checks for where the ball position is and then moves the computer relative to the ball position so it'll be able to hit it and then move towards there. Now, let's just set computer speed to 5 right now, just the same as the player speed, so it'll be fair. We can change it more in the Unity editor if we'd like later. So now you can go back into the Unity editor and wait for it to compile. Now, we are going to go to the computer paddle and then add the computer paddle script to it. So we can, another way to do this is to take the computer paddle and then drag it into here. And then we have this message right here that says can't add script component computer movement because the script class cannot be found. Make sure that there are no compile errors and that the file name and class name match. So the easiest way to do this is to go back into here and check if there's any errors. If you see any red marks, there is no errors. And then if there is no errors, then you can just reload Unity. And I found the best way to do that is just to create a new C# script, just keep the name new behavior, and then we can just delete this script again. This will reload the Unity editor, and then once it's reloaded, it will figure out that the computer movement script is all good and we can add it to the computer paddle. But deleting scripts do take a long time, so once your Unity editor finally compiles, you can add it to your computer paddle script. So go to the computer paddle, we'll add the computer movement script to it. It's going to look for a rigid body 2D reference, so we can just drag in our rigid body 2D, and then the ball object reference. So we can just take our ball from the hierarchy and then drag it into the computer movement script. So now let's create a new C# script. We can name this ball movement. Now this ball movement script will only have one method in it right now, just because we aren't going to need, the ball needs very little code to be able to work. So let's delete this and get a public reference to our rigid body 2D. We can name this again rigid body 2D. And then we're going to want to have another public float. We'll name this ball speed. We can set this to 5 as well. Now, let's create a private void method, and we'll name this start ball. Inside of this method, we're going to check if the ball is we're going to start the ball moving in a random direction. So to do this, we can do a random.value, and we can set a float x value is equal to random.value. We can do this again for the y. We can do float y value and set this equal to random.value. And then now we have this here. We can set a rigid body 2D dot add force. And now that we have our random values, we can do a new vector2, and then for the x value, we can do x value times ball speed, and then y value times ball speed. This is just making a random value so that the ball won't go in the same direction every single time. So we have this, but this will always only go in the positive direction towards the computer side, and we don't actually want that. So we can create another float, and we can this will just be a random number, so we can just name it random number, and we're going to set this equal to a random.range, and it's going to be 1 to 3. Now let's create an if statement, and then if the random number is greater than 1.5, then we're going to want to do this. It's going to go towards the computer side, and we can move these x values back to the beginning of the method, or else we'll get an error because the x value and y value won't have been made yet. And then else if the random number is greater than 1.5, we can do a rigid body 2D and add force, and then it will basically be the same, except instead of doing x value and y value times ball speed, we're going to want to do negative x value times ball speed, and then negative y value times ball speed. Now, when we have the negatives, it will go towards the computer side. So this is just checking if the random number is just greater than a few random numbers. And this is just so all of this will be random. So now we can go into the update method. And then right now, instead of creating a button to do this for us, we can just check if input.getKeyDown, and then you can choose whatever key you'd like for this, because this is just for testing purposes, but I'm going to do keycode.e. And then inside of this, we're going to call our start ball method. Eventually, we're going to have a button for this, but right now, we're just going to, for testing purposes, we're just going to see if the E button is pushed down, we can do the start ball method. So you can go back into your Unity editor and wait for it to compile. Go into the ball script, the ball game object, and then drag in the ball right into here. It's going to look for our rigid body 2D, so we can drag in our rigid body 2D reference. And then this game is pretty much finished except for one thing. So inside our assets, inside our project folder, let's create a new folder. We can name this materials. This is going to be all the physics materials 2D. So inside of the materials folder, let's right click, create 2D, and then physics material 2D. Let's name this bouncy. So inside bouncy, we can set friction to 0 and bounciness to 1.005. Now, the friction to 0, we can set the friction to 0 because we're going to add this to the ball. We're not going to want the ball to have any friction because it's just going to bounce all around the screen. And then bounciness, we're going to set to 1, so when the ball bounces off a collider, it will bounce off the walls. And then 1.0005 or 1.005, because whenever the ball bounces off, we want it to get a little bit faster every single time, so that eventually it will just be going really, really fast and it will be a fun game. So inside ball, for our rigid body 2D, inside the material, it says non-physical material 2D, we can add our bouncy to it. Now, right now, the ball will just go shooting out, but we don't want that. So we are going to add colliders to the edges of our screen so that the ball, when it goes to the edges, it won't bounce off. So let's create an empty game object. We'll name this left wall. We can add a box collider to this, and it's going to be right there. Let's reset this transform, and then we're going to want to edit the collider. We can edit through the size. So the size right now, we don't actually want a box collider. We want a box collider 2D. For the size on the X, we can just do 1, and then a Y, we'll do 10. Because this is the left wall, we're going to have an offset of -9 or -9.5 on the X, but that's just a bit too much, so we can do -9.2 or -9.4 or 3, so it's right there. And then you can actually just duplicate this. So by clicking Control D, we'll just duplicate this. We'll name this right wall. And then instead of -9.3, we'll just put +9.3 right here. So together, we have those two things. Now let's create another empty. We'll name this top wall. Reset the transform. Add a box collider 2D to it. The offset on the size, we'll keep the Y the same this time, and on the X, we'll do 15 or 20. And on the offset, we'll offset the Y by, let's say, 5, or maybe 5.7, or 5.5, 5.4. We want it just in, just so the ball doesn't accidentally break out of the collider and then go out. We can duplicate this top wall, name this bottom wall, and then instead of 5.4, we'll do -5.4. So if we highlight all of these, we can see that we have a box around here that the player and the computer can't go out. So we can right now just check if the player paddle has the player movement script, and then they're all there. The computer has the computer movement script, and the ball has the ball movement script on it. So right now we can just play test our game. If we have done everything correctly, we should have a working Pong game, except for the fact that there's no UI to it. We're going to want to add score and a lot more UI screens to make this game look a lot better. But first we need to check if the game works at its most basic state. So once you click the play button and the Unity editor starts the play, you will just have a screen just like this. You can click on here and then click E, and you can see that the ball is moving very slowly. We can, inside of our code, set the ball speed to 5. We can set the ball speed to now something like 60 or something, so it gets much faster. And then we'll go back into our Unity editor. Inside of our Unity editor, we can now go, once the Unity editor compiles, we can go into the ball script and check that the ball speed has changed from 5 to 60 once the Unity editor finishes compiling. Once the ball speed is up, it will be able to move much faster and then move like the way we would like it to. So inside of ball, the ball game object, we can go down, check the ball movement, and then the ball speed has not been set to 60, so we can just set it to 60 here in the editor. So if we click play again, wait for the Unity editor to compile, and then see if the ball moves much faster. We should also be able to move the player paddle up and down. The computer paddle should also move towards the ball just when the ball is moving. So right now, we'll click E, And then you can see that we can move our player, but our ball is moving very slow and our players are being very, very bouncy. So we're going to want to change with these values a bit. So for the computer movement, or the player movement, we can set the paddle speed to something more of like 10. The computer movement, I think we can change these. We can flip these too. So we can Command X and then add that there. And then this we can add to this if statement because I messed up the values, and then now that should work. And then the ball, I think it still needs to move much, much faster because it's still moving very, very slow, and it should be able to bounce off all of the colliders that the screen colliders have. So once our Unity editor finishes compiling, we can check that all of our values have been updated, and then we can tweak with the values in the editor if they have not, and then we can playtest our game again. Now once our Unity editor is fully compiled, we can go to the ball. We can set this to something like 150, so it just goes much, much faster. Player paddle, you can check. Paddle speed, set this to something like 10. We can also set the linear drag to something like 1 or maybe 0.05. And then the computer paddle, you can set the computer speed to something like 10 too. So now, once we click the play button, the Unity editor should compile, and we will be able to play our game. We can click the E button or whatever button you have chose, and then the ball will start to move, and then it will bounce off all of the colliders and then bounce. We can move up the player. So we'll click E. We'll see that we have a working Pong game, except for the fact that our computer paddle is just going up and down. See, you can see it follows the ball, and then there you go. We have a working Pong game. Something I would like to change though is that inside the main camera, instead of having it as this bluish color, set it to black. And now I would like to create some UI. So inside of our assets folder, inside of, I am going to pull in Square, a font named Square. This will be all in the GitHub files of this video, in the description of this video. And then right now we have a font. So I'd like to create Score. So we can go into the hierarchy, UI, and then a canvas. We can name this Score Canvas. It is very big and it's just on the game view. Since there's nothing on it, you cannot see anything on the game view right now. But let's create UI Text Mesh Pro. And then we will need to import the Text Mesh Pro essentials for us to be able to use it. Text Mesh Pro is a better version of the text editor that Unity used to have, and it allows us to customize our text much more and make it look a lot better. So you can click Import TMP Essentials, and then it will add another folder to your Assets folder inside of your Project folder. And then we will be able to use the TMP Essentials, and we can X out because we don't need the examples. And then right now you can see that I'm in the Text Mesh Pro folder. And then in our console, it says TMP Essentials have been imported. So this text, we can name this player score text. and we can just set this to 0 right now. We can set the font size to something like 108. We can align it in the middle. And then we're going to want to change this font to our square font. But as you can see, if we go into here and then try to drag this font into here, we aren't allowed to. That's because that's a TMP font and not just not the font that most other things use. So we can right click on our font, create a text mesh pro, and then a font asset. It will just create a duplication of the square font into a TMP font, so that when we go into the player score text, we can drag this into that, and now we have a blocky 0. I'm going to change, I can move that up a bit. So I'm going to reset the positions, set the width to 200 and the height to 150. The position on the Y I'm going to set to something like 400, and then the position on the X, negative 150. We can also just duplicate this and name this computer score text, because the computer score will be exactly the same as the player, just opposite. So instead of negative 150, we can just put positive 150, and there you go. If we look in our game view, we can see that we have those two things that show the score. That is very good. So now inside of our score canvas, we can get out of our score canvas, and we can create another canvas. And I'm going to name this win canvas. This is going to have all of the text for when either the computer or the player wins the game. So the score canvas, I'm just going to turn this off right now. Inside of the win canvas, I'm going to create a UI text mesh pro, and I'll name this player win text. Inside the text, I'll put player wins with some exclamation points. The fonts, I'll put square. And the font size, I think something like 136 would work good. We can align this in the middle. And then we're going to want to make this just a bit bigger. So I'll set the width to something like 750, the height to something like 200, and then reset the position. I'm actually going to set the position on the Y something more like 150, so it's just up a bit more. We can also duplicate this player win text, name it computer win text, and it will be the same exact thing, but instead of the text for play, we're going to set this to computer wins. So right now we can just turn off this, we can see what this looks like, and then as you can see, those two texts will show when either the player or the computer wins. So inside of the win canvas, I'm also going to create a UI button, text mesh pro, and I'm going to name this reset button. You're going to have this button when one of the player or the computer wins, so you can reset the game and play again. As you can see, it's very small right now, and inside of the button, there's a text. We can name this, inside of the text, we can type reset, because that is what we want it to say. We can set the vertex color to white right now. You won't be able to see it you won't be able to see it very clearly because the button also has a white background, but we can also set the font size to something like 72. Inside of the button, we can set the color, the alpha to 0, the normal color alpha to 0, and the highlighted color alpha to 0, because all we would like to see right now is just the reset. That green line is where the button is, so we can actually just make this much bigger. So for the width, we can put 300, the height, 150. We can reset this, and then let's just put the win text in, and we can see that the reset is much too high. So in the position on the Y, we can do negative 100, or maybe even negative 200. So this will be the screen when the player wins, and then this will be the screen when the computer wins. We just need to set up the game manager script so that it will be able to show these screens when either the computer or the player wins. So inside of our win canvas, I'm going to turn this off right now, and then inside of our score canvas, we can turn this back on, and I'm going to create another UI button, and I'm going to name this Start Button, because right now we are just clicking a key on our keyboard to start the game. But wouldn't it be much nicer to be able to click a button to have the game start? That's what this button will do. So inside of the text, we can just put Start. Inside of the font asset, we'll put Square. We'll name the font. We'll have the font size to something like 72. For text color to white. And then for the button, we're going to change the colors back to 0, the alphas to 0, because we don't want to be able to see this. We're just going to want to see the text. And then we're going to make this just a bit bigger. So we're going to reset the positions. I'll set the width to something like 400, the height to something like 100. The position on the Y, I'll set to 400. It will be aligned with the score texts. And then the position on the X, I can set to something like 600. So it's just over there. So this is what it will look like in the game view. You'll click the Start button, and this ball will start to move. So now that we have our win canvas and our score canvas, we can create, inside of the scripts folder, we can create another C# script named Game Manager. Now, most Unity games have Game Manager scripts, so Unity knows what to do with a Game Manager script and can help us with it sometimes. So once we open up this script, we can just delete this. This is going to be a very busy script because we're going to need all of the buttons in it. So first, let's have a public reference to the player, or a float for the player score. We have another public float for the computer score. And then we're going to put two methods for adding to the player score and then adding to the computer score. You can also set these both to 0 right now. And then instead of a float, you can change these into integers because they will only be one number and we don't actually need to have it as floats. So down at the bottom, let's create a public void, and will be add to player score. The reason this has to be public is because we were going to call it in the ball movement script when the ball collides with like the outer edge of the computer. So when it collides with that, we can just do this, player score plus plus. That is shorthand for writing player score plus 1. So we could just do player score plus plus. And then we can also create a duplicate of this method, a public void add to computer score, which will do exactly the same except for the computer score. So computer score plus plus. Inside of our ball movement script, we're going to want to add another Unity built-in method called onCollisionEnter2D. It has a parameter named collision2D and just named collision. The collision2D is the thing that this ball, or whatever this script is attached to, is colliding with. So we're going to want to check if collision, the thing that it's colliding with, .gameObject, so the game object of the thing that we are colliding on, not just the box collider or circle collider, .gameObject.tag, and we are going to check to see if this tag is named player score. We are going to create these tags in the Unity editor, so it's just going to have the player score, and then we can just have another if statement, if collision .gameObject.tag is equal to computer score, and then we can go into the Unity editor right now and actually add these tags. And these tags are going to be in the left and the right walls. The left wall will be right here, so we can name this tag computer score, because when the ball hits it, the computer should score a point. The right wall, when the ball hits it, the player should score a point. So we can go to the tag, add tag, and we can add player score tag. We can also add the computer score tag, and we can add them to the correct walls. So this will be the computer score tag. This will be the player score tag. So inside of here, we have these two if statements, and inside the player score, we're going to want to call the add to player score. Inside the computer score, we're going to want to do add to computer score. So inside of our ball movement, we're going to want a public reference to our game manager script. We can just name this game manager, and we can add this in the editor because the game manager will be just a random game object that we have inside of our Unity. So down here in player score, we can do game manager, and since the player score or add to player score method is public, we can do add to player score. And then this just adds to the player score. You can do the same exact thing for the computer. Game manager.add to computer score. The parentheses call the method. And then now we have this. So now let's check for if the game is over. So let's create another. We can actually just have this private for now. If we need it later, we can always do it public. A private void. I will name this check for game over. And inside of this game over, we're going to check if player score is equal to 5. 5 is just a relative number, and that is just checking. That's just the end goal of my game. If you want yours to be 10, you can always change this to 10. That's just going to be the max score for my game. Then we can also add another if statement, if computer score is equal to 5. So if the computer has 5 or if the player has 5. So inside of these two things, we're going to want to display the computer wins text and the player wins text. So let's have a public game object, and we can just name this player wins text. We can also have another public game object. We'll name this computer wins text. Computer wins text. And then these are game objects because we're going to want to be able to turn them either on or off depending on either the player or the computer winning. So if player score equals 5, that means the player won. So player wins text dot set active, and set this to true. That means it's just going to turn it on. Let's set the computer wins text to false. And then we're also going to want to set our score and the start button, all of that to false. So let's create another public game object reference to our score canvas. We can just turn all of that off just because we're not going to need any of it. So we'll set score canvas dot set active to be false. Inside of the computer score, we'll set the player wins text to false. Wins text. we'll set that to false. We'll set the computer wins text to true. Set active to true. And then we'll set the score canvas. Again, we can set this to false. Because no matter if the player or the computer wins, we don't want to show the score while it's happening. We also don't want to show the game. So we're going to also have another public game object reference here, and we'll just name this game. We can just, when this happens, just set game.setActive to false, because along with the score, we don't want to be able to see the game. And when we set it active, all of the movements will stop, so you won't be able to control the player. And then, as this is just a method not being called on its own, up at the top, we can add the update method that's called once per frame. And then inside of here, we'll call check for game over, because we're going to want to check for game over once per frame. So we can go back into Unity, and then we're going to need to create a game manager component, because all of these things are going to have to go somewhere. So we're going to want to have to create that. We are also going to create a start menu that will have a few buttons that say play and all of that stuff. And then, so inside of the hierarchy, we can right click, create empty. We'll name this game manager. We can reset the transform and then add the game manager script to it. And it's going to look for a lot of references. Player wins text, that should be in the win canvas. We can right now turn this win canvas on, and then turn all of the player wins text on, but turn everything off. So the player wins text will be in here, computer wins text will be in here, score canvas be right here, and then game, we'll have to create that. So we'll create an empty, we'll name this game. Definitely have to reset the transform. And then the player paddle, all the way down to the bottom wall, we can put all of this inside game, because that's just the game. The game manager, we'll drag the game into here. Then I just realized that we'll also have to set the reset button to true. So we can go back into here, inside here, we can get another public game object reference. We'll set this reset button. And then for both of these, either the computer wins or the player wins, we're going to set reset button.setActive to true, not false, true. Because you're going to want to be able to reset once you finish the game or the computer finishes the game. Once we finish up our code, we can go back into the Unity, and once it completes its domain, we can once it completes its domain, we can add the reset button to the game manager, so it will be able to turn on and off depending on which the player or the computer winning. And then we'll create the UI for the start canvas, because that is very important, because we'll want to have a start canvas to be able to start or quit this game once you start at the beginning of it. So the Unity editor does sometimes take a very long time to compile, so be very patient when yours is compiling. So right now, we can check if the game manager has a reset, and it does right there. So we can just drag the reset button into here, and there you go. We have that. And now let's create UI canvas. We'll name this start canvas. because all of the things that we're going to want for start be in here. So right now we can turn the score canvas off because we don't want to be able to see that. So let's create a UI text. We can just name this Pong text. This will just display the name of our game, Pong. We can square, we can align this in the middle, and then for the font size we can do something like 108 again, and then we can make this much bigger. Reset the position on the X and Y. For the width, let's do 500. The height, we can do 200. The position on the Y, we can set to 200. And then right now, we have that. We can see, or right now, we can just turn our game off so we can see how this looks. Maybe we can make this Pong text just a little bit bigger, so maybe 136. We can check how that looks in the game. That looks much nicer. So inside of Start Canvas, let's create another UI button. Just name this Start Button. This will be different from the Start Ball button because this is just going to go into the game. So for the text, we'll put Start inside of it, set the font to square, font size to 72, vertex color to white, align it in the middle, and then inside of the button, we're just going to turn all of these alphas to 0 because we don't need to see the button, we just need to see the text. Then you can click on the text. So we're just going to make this a bit bigger. We can reset the position. The width, we can do 300. The height, 150 or 125. And then the position Y, we -50 we can put. And then, as you can see, you'll just click on the Start button right there. And then, let's just duplicate the Start button, and we'll name it Quit button. Inside of the text, we'll just have quit. Instead of 72, we can do 63, something like that. And then the position, we'll do it's just -200, -300, maybe. So we'll just have a small quit button down at the bottom that will quit. So this is just our start canvas. Inside of our game manager script, we're going to need to add methods for all of the buttons that we have. So let's start. A public, because we're going to need to reference this inside of the Unity editor, a void. Let's on start button clicked. We'll start with the start button. And then in this method, we're going to want to have some more game object references. So public game object, start canvas, and then right now we're going to, on the start button, we're going to turn the start canvas off. So start canvas dot set active. We're going to set this to false. And then we're going to set game to true because you're going to want to be able to play the game once you click the start button. And we can also set the score canvas to true because the score should start displaying once you click the start button. So we'll set the score canvas to true. And then we can just create another one of these methods, a public void on quit button clicked, because that is also in our start canvas. And this one's going to be really easy. We can just do application.quit. This doesn't do anything in the editor because you can't really quit a game when you're not even playing it. And inside the editor, you're not really playing the game. But this will just quit the application, so you're done with it. But inside the editor, we'll want to see if this is working or not. So we can do a debug.log, and then we'll just say quit game. That way we know that our button is working. So let's do a public void on reset button clicked. The reset button will be displayed once either the player or computer wins. So on the reset button clicked, we'll want to set the player wins text to 0, or we'll want to actually set active to false. Since we don't actually know whether the computer won or the player won, we can just set the computer wins text to dot set active. We can set this to false too. We're also going to want to set this button to false. This will probably be false anyway. But we're going to the start canvas. We're going to want to set that to false. This is just troubleshooting. Just if any of these accidentally turn on, we're just going to want to turn them all off. So we're going to want to turn the start canvas. We're going to want to game.setActive. We're going to set this to true because we're going to want to play. But right before that, let's set computer score. We're going to set this, not computer wins text, computer score. We're going to set this to 0. And then player score, we're going to set this to 0 too. So that's our on reset button clicked. Now we can do a public void on start ball button clicked. This is very important. It's going to be different from the start button, but not really. So inside of this, we're going to want to call this method start ball. So right now we can just delete the update method inside of here. The start ball won't be called, and instead of private, we're going to make this public because we're going to call this when we click the button. So public void start ball. Inside of the game manager, let's get another public ball movement reference. We'll name this ball movement, just so we know it's the ball movement script and not the ball movement, the ball game object. So down here, we're going to do ball movement, and since it's a public method, we can just call start ball. Yeah, so that's on the start button clicked, and most everything else should be turned off by then, so I don't think we're going to need to worry about that. But right now, we're actually not resetting, we're not actually setting our player score and computer score to their actual values inside of the Unity editor. So up at the top, we're going to type using TM Pro. This is using Text Mesh Pro. So we're going to want to use this because we're going to need to set the text values of the computer, the text of the player score and the computer score to their integer values. So let's have a public text mesh pro GUI reference, and we're going to name this player score text. We can have another public text mesh pro GUI reference to the computer score text. Now, once we have these two things, inside of update, before check for game over, just why not, we're going to set the player score text dot text. So we're going to want to access the text value of these, and we're going to set it to player score. Now we are going to get an error right here because player score is not a string, but the player text is looking for a string. So we can just do the method to string, and that's basically just changing this integer value to a string. So let's say player score was 3. That is an integer, but it's just changing 3 to a string. So now it is we can display it. We can also do that with the computer. So computer score text dot text. We're going to set this to computer score dot toString. So we're going to need to have a lot more references and then inside of our Unity editor. And then we're also going to have a lot more. We're going to have to set up a lot more buttons by putting the right methods on them. But that once we have finished that, we will have finished most of all of these, most of the Unity UI, and we will have a pretty much a working Pong game. So inside of our game manager, once the Unity editor compiles, inside of the game manager, game object, we have a lot more. So the ball movement inside of game, just put ball. Player score text, that will be in the score canvas. So player score text right there, and then computer score text right here. And then all of these buttons, so not in game, but in the reset button right here, the start canvas, the start and quit buttons, and then the main right here, this start button, we're going to need to add the button components to them. So down at the bottom, we have an onClick method here, and it says list is empty. So we're going to click the plus sign, we're going to add to the list, and for none, we're going to drag in the game manager. So instead of putting a no function, since this is the start button, but not just the start button, this will be the start ball button. So we can do the game manager to go into the game manager script, and it will be on start ball button clicked. Since it's public, we'll be able to reference it from here. So once we click this, it will call this method. So inside of the reset button, we can drag in the game manager for the object, and for the function, game manager on reset button clicked. Inside of start, we're going to click an on click game manager on start button clicked, and then in the quit button, we're going to put in the game manager and then on quit button clicked. So now if we turn off everything that needs to be turned off, so everything is good, we can close up all of this so we just see what we need to see. We can start this game and we can see what we have as of right now. Once the Unity editor compiles, we should just be able to see what we have right here in the scene view. We won't see the game right now. We will just see this this canvas, the Pong, the start, and the quit. When I click on the quit button, I should get a quit game, and I do down here in the console. See, every time I click this, I'm just calling this method, quit game. It will call this, but since it does nothing in the editor, we don't actually need to do anything. So we'll click start, and then we'll get an unassigned reference exception. The variable start canvas of game manager has not been assigned, and that's okay. That just means we missed something here. So inside of here, the start canvas, it's just going to be this. Now that unassigned reference exceptions are very common in Unity when you have big scripts like this. So when you have to assign all of these values. So we can just clear the console and then start to play again. Now it should work because we seem to have assigned all of our references inside of the game manager script. So when I click the start button, it should show the game with the ball. And then after this, we can put the ball back into the beginning, ball back into the middle. So we'll click start, and we'll have right here. See, the ball is not in the middle, but if we click start, then the ball starts to move. We can move the player. The computer starts to move. And then we have a working Pong game right here. So we have a null reference exception again, object reference not set to instance of object, on collision 2D, ball movement, and the object reference not set to instance of object. If we double click on here, we can see right where this was. It'd be game manager, add to player score. So inside of the game manager, add to player score, just player score plus plus. And then inside of our ball movement, if the tag is player score and then computer score, what we need to do is check if these two things are player score and computer score, and they seem to be. So what we can do right now is just turn off the start canvas, turn on the game, turn on the score canvas. This will be messing up some of our UI right now, but we don't need to worry about that because we can turn this all off and back to our normal things once we have finished this. Once the Unity editor compiles, this type of thing is very common, so we can just click start and the ball will move here. I can move the player up and it will give us another no reference exception. These are all just on the balls. So what we'll need to do right here is just go down to the bottom, and it says, and we don't have the game manager script attached to the ball. That was the whole entire problem. So once we do that, we can reset this. We can turn the game and the score canvas off, turn the start canvas back to true. It does take a while to get finally into the game, but once we do, we'll know that we have everything set up. And then whenever you get errors like that, you can always double click on them and you can check in the code where it is. If there's no editors in there, you can go to the game object and then check if you have assigned everything, or if you'd like, you can always just copy and paste it into Google and see if other people have gotten the same error as you. So we'll just click start, go over here. I'll move the player down so that the computer will get a point. This is kind of unfortunate because the ball is just going up and down, not at a very steep angle, not actually going across the board very fast. But as you can see, it is slowly gaining speed, so that means our bounciness is working. So eventually, once the computer score reaches 5, we should get the computer wins text, and the reset button should appear. If we click the reset button, it should bring us right back to this screen, and we could be able to click start and play the game again. But we just need to test this. So there you go, we have the computer wins, but the reset button doesn't appear. So we probably just in the game manager, inside the on or check for game over, if the computer score, the reset button, we set this to false. We can set this to true. Now, just to make our playtesting lives just a little bit easier, and so it doesn't take a long time for us to playtest, we can just set, inside of the Unity editor, set our computer score and player score to 4, just so that the next point will win, just so that we don't have to wait for either score to go up to 5 to place test to see if this will work. So once the Unity editor finishes compiling, we can go to the game manager and just for playtesting purposes, change these values. See, it's nice when you have public references because then you'll be able to just change them in the editor when you'd like, and then it will always work out because you can just change it back and you don't have to go all the way into your code to change it. Change the values of some float values or integer values or string references or things like that. So once we enter play in the Unity editor, we'll come across a screen like this, click start, and you can see it just says 4. And then we have player wins. Reset. And we come across this problem right here. First off, the score canvas isn't here, and everything is where it used to be. So what we'll want to do is on the reset button clicked, we're going to want to put the score canvas dot set active. We're going to set this to true. Now we're going to need references to all of our game objects. So we have so we could just do public game object player paddle, another public game object. We can name this computer paddle, and then another public game object. I'm gonna name this playing ball. So now inside the reset, we can set playing ball dot transform dot position and we're going to set this to a new vector 2 because the positions are vector 2s. And we're going to set this just to 0, 0. We're going to set computer paddle dot transform dot position, and we're going to set this to a new vector 2, and this will be positive 7.5 and 0, 7.5 f 0, and then make sure to spell your variables right. And then we're going to do this one more time. Wow. Transform for the player paddle dot transform dot position. And we're going to set this to a new vector 2. And this, instead of being positive 7.5, it will be negative 7.5. And then 0 on the y-axis. Negative 7.5f. Whenever you have float values, so or decimal places, you always have to put an f next to it because that just specifies that it's a float and makes it much easier. So now it should work, this game, and we should be pretty much finished. So now that the reset button, once it clicks, all of the values will go back to their normal positions, and then the score canvas will be set up, and then the score canvas will display the right things because we set the player and computer score back to 0. So, and then we set all these transforms back to 0. This game manager script is definitely very large, but it helped us do everything that we needed to do. So, since we don't need to playtest this again, since it will work, we can set these values back to 0, and then we are finished with this tutorial. There are a few things that you can add if you would like to. You could add difficulties by just changing the ball speed, so the ball will go faster and faster and faster, so that's more difficult to catch it. You can also change the values for game over. You can set these to 10, so you'll be playing for longer. There are so many different things you can add to this game that will make it that you can customize it just for your liking and make it more fun. Pong is just a very basic game, and I added just all of this UI to it, and it made it look much better than just the original. But there are a lot more things you can add to make it much more nice than the one that we have right here. Thank you for following along through this Pong tutorial. I hope you learned something today, and I hope you will follow along for the next tutorial. Make sure to like and subscribe, and click the notification button to be able to find out all of the new videos that I'll make. Thank you.